Hello and welcome to your Algebra 2, Chapter 6.5 lesson on the remainder and factor theorems. So today we're going to be dividing polynomials, and what we have here, this might look a little odd here at the beginning, but what we have is just some polynomial divided by another polynomial. What you get when you divide is you get the quotient, and then you would have the remainder over your divisor. So for instance, and we're going to be doing long division today, so if we take 512 divided by, let's divide it by 5. So if you remember long division, you'd say, well, 5 goes into 5 once, and so then we multiply and get 5, and then you subtract and you would get 0, and then you bring down the 1, and then 5 goes into 1 0 times, multiply, subtract, we're going to get 1, and then we bring down the 2, and 5 goes into 12 twice, and I'm going to run out of room here, but it would be minus 10, which would be 2, and so we're going to have a remainder. That's our remainder. But how you write that, and if you remember way back in elementary school, you used to get to write remainder 2, but we're going to be a little past that here. We are going to write plus 2 over 5, because that would represent 2/5 still, because you'd have to divide that 2 by 5. And so this is what we have here, that this is the whole number part of the quotient, and then I have my remainder still over my divisor, okay, because what you divide by, so in this case our 5 is our divisor. So that's what that means there. The degree of the remainder has to be less than the degree of the divisor. So in the case of just numbers here, the 2 has to be less than the 5, because otherwise you could have said, okay, 5 can go into that. So we're going to actually be doing this with polynomials, so you're going to be looking at maybe something of degree 1 where you were dividing by something of degree 2. And remember, you can always check division by using multiplication. So if I wanted to, I could take 5 times 102 2/5, and I should get 512. So how do we do long division with polynomials? Okay, well, first of all, we set it up the exact same. So I'm going to divide y to the 4th. Now I need my missing terms. So I'm going to say plus 0y cubed plus 2y squared minus y plus 5. We're going to divide this by y squared minus y plus 1. And then you're going to ask yourself how many times or what times y squared makes y to the 4th. So just looking just at this leading coefficient or this leading term here, what times y squared makes y to the 4th? Well, the answer should be y squared. So we're going to put a y squared here, and I put it there because this is going to be my y squared column. Okay? And then we multiply. So what is y squared times y squared? That's going to be y to the 4th, so we're going to put it in our y to the 4th column. And then what's y squared times negative y? That's negative y cubed, so I'm going to put that in my y cubed column, which is why we needed a y cubed column. And take y squared times 1, and that's going to be y squared, so it's going to be plus y squared. So we multiplied. And remember, the next step is to subtract. So I write it like that. If you want to, though, you can distribute. So it'd be that becomes a minus, a plus, and a minus. So then y to the 4th minus y to the 4th cancels. 0y cubed plus 1y cubed is going to be a y cubed. 2y squared minus a y squared is going to be a 1y squared, and minus y. So there's our first step. And then we start over. Y squared times what is y cubed? Well, the answer is y. So it's going to have a plus y. And then we multiply. Y times y squared is y cubed. Y times negative y is negative y squared. Y times 1 is y. Okay, and then I subtract, and again, if you want to change your signs, plus, minus, there we go. So y cubed minus y cubed, those should always cancel. Y squared plus y squared is going to be 2y squared, and negative y minus y is negative 2y, and we need to bring down our plus 5. All right, and this will be our last step, especially because we're almost out of room here. Y squared goes into 2y squared how many times? Y squared times what is 2y squared? So the answer is 2. So plus 2, this is now my constants column. So if I multiply, I'm going to get 2y squared minus 2y plus 2. And I'm going to subtract those. My y squareds are going to cancel. My 2y's are going to cancel because it's going to be negative 2 plus 2. And I'm going to get 3 as my remainder. So then we need to write our remainder. I moved it over a little bit for us. Plus 3 over what we were dividing by, which is y squared minus y plus 1. That is your answer. So it did not divide into it evenly because there was a remainder. All right, we're going to look at one more of these. Okay, so this time we're going to divide 2x squared plus 13x minus 7. Divide that by x plus 6. Okay, so your first question is x times what is 2x squared? So the answer should be 2x. So we're going to put a 2x in our x column here. And then we multiply. 2x times x is 2x squared. 2x times 6 is 12x. And so notice we match up like terms. Then we're going to subtract. So 2x squared minus 2x squared cancels. 13x minus 12x is x. Bring down the 7. And then x times what is x? Well, that's 1, so plus 1. So if you remember, the degree of the remainder has to be less than the degree of the divisor. And at the moment, if this whole thing was the remainder, it has a degree of 1, but this also has a degree of 1, so we're not done yet. So it goes into it one time, so then I multiply, and I'm going to get x plus 6, and then I'm going to subtract, so x minus x cancels. Negative 7 minus 6 is negative 13. There's my remainder, so I'm going to say minus 13 over x plus 6. So again, did not go into it evenly, and that's fine, because there is that remainder there. So this brings us to our remainder theorem. And our remainder theorem says if we have a polynomial f of x and we divide it by a linear binomial, okay, so this has to be degree 1, so just like the problem we just did, then the remainder is the same number you would get if you evaluated your polynomial for k, and there's k. And notice the minus sign is in there. So we just divided 2x squared plus 13x minus 7. That was our f of x. We divided it by x plus 6. So notice that'd be the same thing as x minus a negative 6. So this says our remainder, which was negative 13, would be the same thing we'd get if we took f of negative 6. So if this is f of x, if I put in a negative 6 for both x's there, so if I had 2 times negative 6 squared plus 13 times negative 6 minus 7, so negative 6 squared is 36 times 2 is 72, and then 13 times 6 is going to be, well, it's minus 78 minus 7, so 72 minus 78 minus 7 is a negative 13. So this says if you do division, that your remainder is going to be the same thing as if you were to evaluate for that number right there. So we're going to use the remainder theorem and then synthetic division to help us divide now. Now, so far I've done long division, so synthetic division is just like synthetic substitution. Okay, so remember we start out with our coefficients. So my coefficients are going to be 1, -1, -2, and 8. Okay, remember to put in zeros for missing terms. But on the outside, I'm going to put 1 because I want, that is going to be that k value from the previous slide. And if this is x minus k, k is a positive 1. So remember, we drop your mama, so we're going to drop, multiply, add, multiply, add, multiply, add. So there is my remainder. Okay, that's my remainder. But my answer here, if this was an x cubed and we just divide it out in x, this becomes an x squared. So this is 1x squared minus 2, because there's no x in the middle there, plus 6 over x minus 1. Okay. So if we want to do the other one, let's see if I can squeeze it in here. We have the same coefficients. We're going to divide this time by -2, right? Because this is x minus k, so k has to be a -2. So we're going to drop, multiply, add, multiply, add, multiply, add. Okay, so if I get a 0, what that tells me, first it tells me two things. First of all, that x plus 2 divided into it evenly. So if this was an x cubed up here, this is going to become an x squared. So this is 1x squared minus 3x plus 4. So it divides into it evenly, which means that this is a factor and it's going to be a 0. Think back to quadratics, and when you factored, those factors give you your zeros. Right now, get the synthetic division down, and we'll talk more in class about using it. So the last thing I want you to have written down is this, the factor theorem. So this is what just happened to us on that second one. If you have a polynomial, which we did, that has this linear binomial as a factor, then if you were to evaluate and you would get 0 if that's a factor. Notice this is an if and only if here. Okay, so going backwards, if I evaluate and get 0, then I know I have a factor, and we're going to use this to help us factor polynomials. All right, I know that's some new stuff, but I hope you took good notes. Go back and rewatch it if you need to. There's nothing wrong with that. Let me know if you have any questions, and I'll see you in class.